Okay, so let's do this question here. So it says, find the density using slope for each substance. So I want you to pause the video and see if you can't find the slope of each substance here. And what I would do is I would just find the easiest points to read, because slope should be consistent. It should be constant. If it's drawn out for you, this line isn't changing, so it doesn't matter which two data points you use. I always like to use the first and the last data point, but use ones that are really easy to read. So do density for substance A, density for substance B. Pause the video and please, please, please don't start it until you try it yourself. It's really important that you can do this on your own. So pause the video, then resume. Okay, so you should not be resuming until you've tried this yourself. So if you're still listening, go ahead and hit the pause button. If you're ready to go, then we're both ready to go. So when I did substance A, I thought the easiest point to read was this one here. So 80 grams and 15 milliliters. So I'll do for substance A, my first coordinates, again, you do x, y, so 50 milliliters. And remember, those coordinates now have units. And 80 grams, and I'm not worried about sig figs right now. I'll tell you when we should worry about sig figs. So there's the final mass and volume. And the other ones are kind of hard to read. So I think what I'm going to do is I'm going to use this point here. That looks like it's pretty much in the middle. If you use 0, 0, that's fine. I don't always recommend it, especially when we start doing data from lab and we have to create what's called a best fit line. But I'm going to use this data point because I think it's fairly easy to read. So that looks like it's 25 and 40 for me. So if you didn't use that data point, that's fine. Our answers might be just slightly different, but that's okay. So I say 25 milliliters is my X value, and then 40 grams is my Y. So what is my slope? It's change in Y over change in X. Change in Y over change in X. So 80 grams is my Y2. 40 grams is my Y1. Remember, this is X. This is Y. And then my X2 is 50 milliliters, and then my X1 is 25 milliliters. So this looks like it's 40 grams over 25 milliliters after we do the subtraction. So 40 divided by 25, I got 1.6 grams per milliliter. If we're off, you and I, ever so slightly, that's okay. So if you use 0, 0, you would have gotten 80 over 50, which is still 1.6. So. All right, so let's do substance B. I'll do it in a different color. So substance B I think is easier to read. Looks like I got a coordinate there that's pretty easy to read, and I'm going to use this coordinate here. Okay, so it looks like my B2 will be 60 milliliters and 30 grams. So for B, I'm going to use 60 milliliters, X, and 30 grams. And you should already be able to make a prediction. Your prediction should be that substance A is more dense than substance B because that slope is steeper. So that should be your prediction before we start. And so for here, I see 30 milliliters and 15 grams. That's what I'll call this one. 30 milliliters X, 15 grams Y. So this is X, Y. And because my X and Y values for that 60 and 30 is further on the graph, we call it X2 and Y2. So just a reminder there. So how do I find slope? Change in Y over change in X. So Y2 minus Y1 over X2 minus X1. And if you ever get a negative answer, something's wrong because density is never negative. It's always going to be positive. Okay? So I got 15 grams over 30 milliliters. So our prediction was correct. Our answer is going to be lower. Our slope is going to be lower because it's less steep. So now I know that substance A is more dense. It has more mass per unit of volume compared to substance B, which has less mass per unit of volume. That means every time I gain 1 milliliter, I'm only going to gain 0.5 grams for substance B. So for question 2, it says if you put 10 milliliters of A in one balance pan, how much of mass of B would you need to make it balance, aka the same mass? Okay, so what they're saying is I have a balance pan, and you're probably like, what the heck is a balance pan? Here it is. And then I say I put 10 milliliters of A. So here's A. Then all of a sudden my balance pan goes lopsided. That's really heavy. So I want to make it balance again. So if I have 10 milliliters of A in here, then how much of B do I need to add to make that balanced pan go back to normal? So balanced pans, they are getting lopsided because one side is heavier than the other. The milliliters doesn't tell me how heavy A is. I need to figure out how heavy A is in order to figure out how much of B I need to add to the other side. So how am I going to figure out how heavy A is? Well, remember, slope is a ratio. If I had 1 milliliter of substance A, so I can rewrite this as saying I have 1.6 grams. That's 1 milliliter. So if I have 1 milliliter of substance A, it will weigh 1.6 grams. So you could think of it as a ratio. How much will it weigh if I have 10 milliliters? Well, if you multiplied one side by 10, you have to multiply the other side by 10. So 1.6 times 10 is 16 grams. Okay? Sometimes it's that easy, where we can just do ratio. Sometimes the numbers get weird. So this is where we start doing dimensional analysis. Density becomes a conversion factor. So this is now your conversion factor. You can get from grams to milliliters. So what should I start with? I should start with information about A. I have 10 milliliters of A. I don't know how much that weighs, but I know if I had 1 milliliter of A, according to my slope, it would weigh 1.6 grams. So milliliters, 16 grams of A. So now I have 16 grams of A. Got 16 grams of A here. So now how do I make this balanced pan the same? I just need 16 grams of B. That's all I need. So you say add 16 grams of B. And now 16 grams of A, 16 grams of B. It's nice and balanced. Okay? So that's what you need. All right, let's do number 3. It says if you put 35 milliliters of B in one balanced pan, what volume of A would you need to put in the other pan to make it balanced? Ooh, this one's a little trickier, okay? So now I'm going to put 35 milliliters of B in one balanced pan. I don't even know what that means. What does 35 milliliters of B mean? I don't know that mass. So I have to match that mass in order for my balanced pan to equal out. So let's figure out what 35 milliliters of B is. So this is where it gets kind of tricky with the math. I know that the density of B is up here. And density means that if I have 0.5 grams of B, it will be equivalent to 1 milliliter. So for every 1 milliliter of B, it'll weigh 0.5 grams. But I have 35 milliliters. So if I multiply this side by 35 milliliters, I'm going to have to multiply that side by 35 milliliters, right? Which is just 17 and a half. So 0.5 times 35 is just 17 and a half. Okay. So now I know that I have 17 and a half grams of B. How do I do that using dimensional analysis? Well, if my conversion factor is for every 0.5 grams, it's 1 milliliter for B. But if I have 35 milliliters of B, for every 1 milliliter of B, it weighs 0.5 grams. And look, now your units cancel, and you get 17.5 grams of B. Okay, so now I know I have 17.5 grams of B, so how do I balance out my balance pan? I need to put 17.5 grams of A. Simple enough. So now they'll go back to normal. So 17.5 grams of B, 17.5 grams of A. But it's not asking how much, it's not asking what mass, it's asking what volume. Yikes. So, okay, I don't know what the volume is, but I do know my relationship to mass to volume. I do know for every 1.6 grams of A, it will be 1 milliliter. So I don't know a number off the top of my head that I can multiply by each side to get this to equal that. I don't know. 1.6 times what gives me 17.5? I don't know. So that's where dimensional analysis starts to become really important. These were easy when I'm just dealing with ones, right? Ones and tens and things like that. It's now getting a little bit harder. So what I have to do is I say, okay, I have 17.5 grams of A. I have no idea how many milliliters that is. But I do know that if I have 1.6 grams of A, it will occupy 1 milliliter space. So 17.5 divided by 1.6 would be 10 point, let's go ahead and do our sig figs. So this was 3 significant figures, this is 3 significant figures, this should be 3 significant figures, 10.9 milliliters of A. Let's go ahead and worry about sig figs when you come back. I want to have a discussion and practice. For now, don't stress out too much with these density calculations. So 10.9 milliliters of A is equivalent to 17.5 grams. And if you're like, I'm not convinced, I don't think that 10.9 milliliters of A is equivalent to 17.5 grams, well, let's prove it. Let's do it. So my density should be, for every 1.6 grams of A is 1 milliliter. So if I do 17.5 grams of A over 10.9 milliliters, will I still get the ratio of 1.6 over 1? So let's see, I'll just divide. So 17.5 divided by 10.9, there you go, 1.6 grams per milliliters. So you can always check your answer. Your ratio should always be the same ratio as your density. Always, always, always. Okay, let's turn the page. Next one says water has a density of 1 gram per milliliter. Sketch the line representing water on the graph in figure 4. So water has a density of 1 gram per milliliter. What does that mean in terms of slope? Well, let's write it like slope. Slope is y over x. So I have 1 gram. Remember, my y-axis is going to be grams. I'm going to go ahead and clear the page. That way it's not too much ink. So my y value is in grams, and my x value is milliliters. So I have 1 gram per 1 milliliter. So every milliliter, every time I move over in my x value, I should move up 1 in my y value. So rise over 1, run. So 10 to 10 is the same thing as 1 to 1, right? So 10 to 10. So if I move up 10 again, I have to move over 10, because 10 over 10 would be the same thing as 1 over 1. And I do it again. I do it again. I do it again. Again, again, again. So now we have a ranking, right? So now we have a ranking. Oh, that's a really bad line. Sorry. So now we have a ranking, right? We say, okay, substance A is the most dense. Water is right here. And then substance B is the least dense. Okay, so let's see what questions they're going to ask me. They say, determine whether substance A and B will sink or float when placed in a bucket of water. So A is more dense than water. It has a steeper slope than water. And we already know what substance A's density was. This was 1.6 grams per milliliter. This was 1.00 grams per milliliter. And this was 0.5 grams per milliliter, as a refresher. Okay, so something that's more dense will end up sinking. It's heavier per unit of volume. So substance A will sink. So let's think of things that are more dense than water, like lead. That's more dense than water. Lots of, like copper, those metals are more dense than water. So what happens for substance B? Substance B will float because it's less dense than water. So I would say objects that are more dense. It doesn't have to be water, but this is the example we're using. Will sink. And then objects that are less dense than water will float. Okay. So we're going to use this explanation. Objects that are more dense than water will sink. Objects that are less dense than water will float to do something what's called water displacement method. And I'm going to save water displacement method for the next set of notes. All right. So on Zoom together, we're going to do problem set 1.3, and then we're going to probably discuss a lab. A lab's coming up next.